Hello friends, in our previous lecture we have completed the third chapter of accountancy, now going for the third chapter of statistics. Now friends, as I said before, that second and third chapter is interrelated. Means if you know or if you understand the second chapter, then only you will understand chapter number 3 of statistics. Name of chapter is linear regression. And the previous chapter's name is linear correlation. Now actual difference between chapter is that in second chapter we have just learning the relationship between two variables, that is x and y. Now if we want to predict any value, if we know one value of x and we want to predict the value of y, then linear correlation is not used for them. For that we need to use regression. By knowing the relationship between two variables and then deciding what is the relation and how is the relation between them, maybe partial or fully relation, and for any value of x we are getting any value of y. So here x is independent and y will be dependent, and finding each value for that, so it will be used by linear regression. So we are writing some of the theory parts for this chapter. So let us start writing. So everyone in your notebook, chapter number 3, linear regression. Again I will tell what to delete and what not to delete, and in accountancy chapter number 3 nothing to be deleted, whole chapter will come. So we are writing some of the theory part, everyone should write. Okay, first we will give the heading meaning. What do you mean by this? So we will write the literal meaning of regression is to avoid or return to mean value the term regression was first used by a statistician, Sir Francis Galton, during his study of human inheritance. Regression is a functional relationship, functional relation between two correlated variables. What thing we have written? Let's read. The literal meaning means the normal meaning of regression is to avoid or return to the mean value. Mean value means average value. The term regression was used by first statistician Sir Francis Galton. You should know this thing during his study of human inheritance. And if you want, you can write this one thing also, that regression is a functional relation between two correlated variables. But the exact meaning is this: is a functional relationship means first we will identify the relation and then we will find an estimated value. So that is the meaning. Now next we will write linear regression model. What is this linear regression model? We will write about it. A set of one or more equations representing a relation or a problem is called a model. A statistical model which describes cause effect and effect relationship between two variables is called a regression model. Okay, so what is linear regression model? A set of one or more equations representing a relation or a problem. So here we want to make equations and which is representing a problem. Problem means the relation between two correlated variables is called a model, and a statistical model which describes cause and effect. As you know from chapter 2, we are learning cause and effect. One will be the cause, other will be the effect. So a statistical model describes cause and effect relationship between two variables is called a regression model. Now, first we will write what is this cause and what is effect variable. We will denote cause variable as x and x is independent variable. We will denote effect variable as y and y is dependent variable on x. So x is independent and y is dependent. So on basis of x we will find y. Yes. Linear regression model is represented as y is equals to alpha plus beta x plus u, where y is dependent variable, x is independent variable, alpha comma beta constant, u is equals to disturbance variable. So friends, this is about linear regression model. What we have written, a set of one or more equations. See, this is equation representing the problem, means you are showing the situation between x and y, that is called a model, and a statistical model which describes cause and effect relationship, that is a linear regression model, and it can be represented as y. We want to find y on basis of x. So we will use two constants, that is x, alpha and beta with x and y. So how can we find y? Y is equals to alpha plus beta plus u. Y is dependent, x is independent, alpha and beta are constants, and u is disturbance variable. Why disturbance variable? Because while creating a relationship between two variables, it is possible that there are some errors. There are some errors occurring in the variable, and that errors is a disturbance variable. Now, what are these errors? I may say that if in your calculator you are calculating and you are getting 133.33333, so sometimes we are taking it as 134. So the remaining variable is error. We have rounded off the value. Now that error, the remaining value is the error of that value. That is a error. Okay. Now exact definition of linear regression is given on next page. We are writing that thing. What is the exact definition of linear regression? The name of the chapter. Okay. So next we will write definition of linear regression. A mathematical or functional relationship between two correlated variables. Which helps in estimating the value of dependent variable for some given value of independent variable is called linear regression. Let me explain. A mathematical or functional relationship, because we are having equation. A mathematical or functional relationship between two correlated variables which helps in estimating. A functional relationship or an equation which helps in estimating the value of dependent variable, that is y, based on some given information of the independent variable x, is known as linear regression. Now, same like previous chapter, methods of linear correlation are graphical method, then Carl Pearson's product moment method, and Spearman's correlation method. In the same way, here also there are two methods. So now give the heading fitting of regression line. So we will write there are two methods. There are two methods for fitting a regression line. That methods are method of scatter diagram. This is not in our course as per government syllabus, but you should know the name. And next is method of least squares. This method of least square is Carl Pearson's only. Means the same formulas with slight change we will learn. Okay, so these are the two methods: method of scatter diagram and method of least square, that is of Carl Pearson only. Now we are directly seeing method of least squares. and nothing is given for the scatter diagram. Okay, so don't worry. Method of least squares for linear regression. For that, so directly we will write the formulas. How will you write? For fitting regression line comma regression coefficient, which is denoted by B. It is denoted by small letter B. Should be found, and then equations can be made. Now we are writing something about this regression coefficient. The value of B obtained by the method of least squares is called the regression coefficient of regression line y on x. Why y on x? Because y is dependent on x. B is also called slope of regression line, and the constant A is called the intercept of regression line. So before starting the formulas, we are having some knowledge about two variables, that is A and B. So what knowledge we will have for fitting regression line? Regression coefficient, which is denoted by B, should be found, and then equations can be made. So for that, one thing is given, the value of B, that is regression coefficient. See, in question in chapter number 2 we are having correlation coefficient R. Here we are having regression coefficient B. The value of B obtained by the method of least square is called regression coefficient. Name of B is regression coefficient of regression line y on x. The second name of B is also slope. B is called the slope. Slope means the change made by two variables of regression line, and the constant A. Constant A is called the intercept. Constant A is called the intercept. So underline these things what I am underlining. So here there are two constants A and B. In the equation we have seen as alpha and beta, but for our easiness we will call them as A and B. So B is the main thing. B is the main thing. In previous chapter, R has 3 big plus 3 small formulas. In this chapter, same formulas with slight change will be for B, and there are 7 formulas. How much? There are 7 formulas. One extra formula is there. So friends, you need to know so much things. Formula for A and then thing will not change, but formula for B are 7. In previous chapter for R we had 6 formulas, 3 big sums and 3 small sums, and here we will have 3 big formulas plus 4 small formulas, so total 7 formulas for B is there. Okay, now we are writing interpretation of regression coefficient B. How can we interpret this B? We have interpreted R, but how can we interpret B? Let's see. B is equals to estimated change in value of Y for a unit change. For a unit change means 1 unit. For a unit change in value of x. So what they are meaning to tell is that B is a slope, as you know. So it shows estimated change in value of y for unit change in value of x. Means it says that if B is 5, then how can we interpret 1 unit change in x, 5 units change in y? Because B is showing estimate change in y. B is 5, so y is changing by 5 units for 1 unit changing in x. 1 unit it is not written in book, but we can understand by a sentence. For a unit change in value of x. So if x is changing 1 unit, x is always 1 unit, and y is b units. Y is b units. So if b is equals to 5, then 5 units are changing in y for 1 unit changing in x. If x is changing by 1 unit, b is changing by 5 units. Now 2 or 3 things is given. B greater than 0. What do you mean by B greater than 0? Unit increase means 1 unit increase in value of x implies means results increase in B units of y. What they are telling? When the answer of B is positive, means greater than 0, unit increase in x means 1 unit increase in x results or implies B units changing in y. Means if B is equals to 3, so it is positive. So 1 unit is increasing in x and it will increase 3 units in y, because implies or results increase in B units. B is 3 units changing in y. So 1 unit changing in x, increasing in 3 units of y. Now opposite to it. If B is less than 0, then what we can write? Unit increase means 1 unit increase in value of x implies means results decrease, totally opposite, decrease in modulus. Why we keep modulus? Because here B is minus, so ignore that minus. Modulus means if in modulus it is minus 3, then outside it is plus 3. If modulus it is plus 3, then outside also it will be plus 3 only. But what is the meaning of modulus? If something is in modulus, then it will have a positive value. Modulus B units of y. Now what they are telling for B greater than 0 and B less than 0, I will explain. B greater than 0, B less than 0. If B is greater than 0, then x is increasing. X is increasing, it will result y is also increasing. Then if b is less than 0, if x is increasing, then y will decrease, and in the same way x will decrease, then y will increase. First you understand that thing. Now how much units? If it is greater than 0, then 1 unit increasing x, then 3 units increasing b, means both are increasing. And here if 1 unit is increasing, other units are decreasing there, so it has a opposite relation. Okay, so you should understand this thing. Okay, now 2 notes are given that are also important. Note 1. Regression coefficient b can also be denoted by byx. Byx means line y on x and in that b. If not required, generally we denote it as b only. In sometimes byx is given, that yx is not required, we will denote it by b only. Second note, points for scatter diagram is not required. R is 1, b is greater than 0, and r is minus 1, b is less than 0. You should remember this thing. R means correlation coefficient of second chapter, because that thing is used in this chapter also. If r is 1, then b is greater than 0, and r is minus 1, then b should be less than 0. So this much things about b you should remember whenever you need to interpret this. Interpretation will come in exercise 3. Don't take tension about that. We will do in exercise 3, but every theory is written down. Now we are writing each and every formulas. Okay? Now we are writing each and every formulas. So these types of sums, friends, these types of sums are solved according to the steps. There are 4 steps to solve the sum. So we will give the heading steps to solve the sum. We have only one method of least squares. In that, what are the steps to solve the sum? So we should give the heading fitting regression line y on x. Whenever you are starting the sum, give the heading fitting regression line y on x. In that first step, heading, you should do the sum by heading regression coefficient, and that is b. B is equals to, as per information in the question, we will have 7 different types of formulas. Explain after steps. After we are completing the steps, I will explain. So first you write, what is the first step to solve the sum? First step is regression coefficient, and regression coefficient is b. What is the formula of b? There are 7 different formulas, and any of the formula is used in the sum, and the sum is solved. And which are the formulas will be explained after the steps. Second step, intercept. What is the second step? Intercept. Intercept is denoted by a. What is the formula of a? A is equals to y bar minus The formula for intercept A is y bar minus bx bar. Third step is fitted. Here we are writing fitting, here we will write fitted. So here we are writing fitting, here we are writing fitted regression line, and this is the equation. We will write y cap, this y is small, and this is a cap, like this. Cap means estimator. Y cap is equals to a plus bx. B is here, a is here, and a and b. So split the values of a and b and make equation. We want to split the values of a and b, and equation will be made. X and y will be as it is. Number 4, estimation. We have to estimate the value of y for the value of x. So y cap is equals to a plus bx. Now put the value of x given in question and obtain value of y. Okay, power supply is gone, so let's wait for 1 or 2 minutes. Okay. So friends, these are the steps to solve the sum. First step is B, regression coefficient. We will give the head first, give the heading fitting regression line y on x in every sum. Then we will give regression coefficient heading. Then we will split the formula of V. Now I am giving which are the formulas. Then intercept. We will give the next heading as intercept. Formula A is equals to y bar minus bx bar. Then fitted regression line. We will obtain an equation by keeping the value of A and B in y cap is equals to a plus bx. Same equation will be transferred in next step, and value of x will be split out, and the sum will be solved. Now various formulas for B. Various formulas for B. Type 1. When x bar and y bar both are integers, means no decimals. Same like chapter number 2, type 1, x minus x bar method, same formula is used, but little bit change. B is equals to sigma x minus x bar multiply y minus y bar upon sigma x minus x bar square. Only slight change. The formula of R was sigma x minus x bar y minus y bar. Now in denominator we were having two terms in square root, that is square root x minus x bar square multiply square root y minus y bar square, but here the y minus y bar term is removed, so only square root is also removed, only sigma x minus x bar square. This is first formula. Then next we will learn only two types of formula now, because in next exercise third type is coming. So we will learn only for 3.1 two types, when x bar and y bar both are integers. Now here, when x bar or y bar is or both are non-integer, means with decimals, with points, and the values are not more than 50. The values are also not more than 50. That xy formula which we were using, same formula but slight change. B is equals to n into sigma xy minus sigma x into sigma y divided by n into sigma x square minus sigma x whole square. See friends, only slight change. Numerator is same for both, only the denominator is changing. In the denominator we were having two terms in square root. Now square roots are removed and only x term is taken, y terms is not taken. So these are the formulas. When x bar and y bar both are integers, then this, and when any one of them is integer or both are non-integers, then this formula is to use. So now for that, understand, first step will have only different formulas. Second step formula will be same, and here we want to just make the equation. In this sequence you will do the sum. Illustration, these headings are not given, but we are compulsorily solving the sums with heading. So people who are not following me, it's not okay. You have to do the formula, you have to do the sum using the heading, not without the heading. And these formula are 7, but now we are learning only 2. After 5 formulas we are learning in 3.2. Till 3.1 we are having only 2 formulas. So now we are going for exercise 3.1. First we are checking that x bar and y bar. Last time we were checking the x bar and y bar for 2.1 and 2.2, like that we will check here also. So everyone, come on, page number 124, take the calculators. First we are finding x bar and y bar like we were finding in the previous chapter. So first question, 12 plus 14 plus 15 plus 16 plus 18 plus 21 divided by number of values are 6. So write there x bar 16, total is 96. So write x bar 16 in the first sum like we were writing in exercise 2.2 and that. Okay. Now for demand, 18 plus 12 plus 10 plus 8 plus 7 plus 5, total is 60, divide by 6. So write y bar is 10. Right, y bar 10. So x bar is 16, y bar is 10. So we can use this formula for B. Now for second sum, time of usage of car, 3 plus 1 plus 2 plus 2 plus 5 plus 3, total is 16, divide by 6 values. So write x bar 2.67. Everyone write x bar 2.67. So we have to use this formula. Then for average annual maintenance, y, 10 plus 5 plus 8 plus 7 plus 13 plus 8, that is 51, divided by 6. Right there y bar 8.5. So both are non-integer, we will use second type. For third sum, 25 plus 32 plus 38 plus 29 plus 31, 155 divided by 5. Right there x bar 31. In the third sum, x bar 31. Then y bar 84, 90, 95, 88, 93 divided by 5. Right there y bar is 90. So x bar 31, y bar 90. Again we will use x minus x bar formula. Now last sum, 12, fourth sum, there is 12 plus 5 plus 10 plus 3 plus 18 plus 4 plus 12 plus 16, total is 80, divided by 8. Write there x bar 10. For y, 83, 75, 80, 78, 89, 68, 88, 87, total is 648, divided by 8. Right there y bar 81. So again we will use x minus x bars method. So in short, if I am telling, there are total 4 sums. 1, 3 and 4 will be done by this method, and second sum will be done by this method. And these are the steps. Let us start. So friends, exercise 3.1. Now if we are talking about the columns, let me not rub that thing. One will be x column, one will be y column. I am talking about this formula. Now one will be x minus x bar, next will be y minus y bar. Next column will be multiplication of both. Next will be x minus x bar square, but don't take y minus y bar square, it is not required. In the same way, for this method, x and y column will be there. We will prepare a column of xy, multiplying x into y, and we will prepare only x square. Y square is not required because here none of the value is y square. Yes. Now let's start the sum. We have discussed the columns. So one less column is there. Yeah. So this is exercise 3.1. First, let's read. From the following data of price in rupees and demand in 100 units of a commodity, obtain regression line of demand on price. Demand is y. See, demand is second column. Demand is y and price is x. So y on x. Also estimate demand when price is 20. This is about estimation. Price X is 20, then demand Y is equals to how much? Okay? Yeah. So first column, price is in rupees, this is X. Demand in 100 units, it is Y. We want X minus X bar, we want Y minus Y bar, we want X minus X bar multiply Y minus Y bar, and we want X minus X bar square. 12, 14, 15, 16, 18, 21, 18, 12, 10, 8, 7, 5. So making the columns is same like chapter number 2 only. The calculations and the steps are different. In the previous chapter we were directly splitting the formula for R. Here we cannot directly split the formula for B. We are having some steps. Okay? So that steps are to be followed. Only that thing is important in this chapter. Keeping each and every step logically. We cannot calculate anything at any time. Sigma X, sigma Y. As you know, this both should be 0. If they are not 0, or this calculation is not possible. Sigma X minus X bar multiply Y minus Y. Sigma X minus X bar square. Okay, let's find X bar and Y. 12, 14, 15, 16, 18, 21, 96. X bar is equals to sigma X by N, 96 by 6, 16 rupees. Y bar is sigma Y by N, 18, 12, 10, 8, 7, 5. Total is 60, 60 by 6, 10, 100 units. Now, X bar is 16, Y bar is 10. 12 minus 16 minus 4. 14 minus 16 minus 2. 15 minus 16 minus 1. 16 minus 16 0. 18 minus 16 2. 21 minus 16 5. Then 18 minus 10 8. 12 minus 10 2. 10 minus 10 0. 8 minus 10 minus 2, 7 minus 10 minus 3, 5 minus 10 minus 5. Let's check this. Okay, minus 4 minus 2 minus 1 plus 2 plus 5 0, 8 2 minus 2 minus 3 minus 5, it's also 0. Now multiply. 8 4s are minus 32, 2 2s are minus 4, 1 0s are 0, 0 2s are 0, 3 2s are minus 6, 5 5s are minus 25. So 32, 4, 6 and 25, everything is in minus. So the total is also minus 67. Now next, X minus X bar square. 4 square 16, 2 square 4, 0 0 0, sorry, 1 square 0, 0 square 0, 2 square 4, 5 square 25. So 16, 4, 1, 0, then 4, then 25. It's 50. Yeah. Obtaining the columns is same like previous chapter. Thing which is different is now. As I said, how we will start the sum by giving this heading. 15 regression line y on x. 15 regression line y on x. First step, name of first step is regression coefficient, that is denoted by b. B is equals to sigma x minus x bar multiply y minus y bar upon sigma x minus x bar square. So this is minus 67 divided by 50. Answer of B is in minus. 67 divided by 15 minus. So it is minus 1.34. Second step is intercept A is equals to y bar minus bx bar. So this x bar and y bar are also important. So y bar is 10 minus in bracket minus 1.34, x bar is 60. Now minus minus will become plus. So 10 plus 1.34 multiply 16. It's 21.44. So the answer of A is 31.44. Now the third step, fitting regression line. Y cap is equals to A plus bx. We want to keep only A and B. Y cap is equals to 31.44 plus in bracket minus 1.34x. So the final equation would be 31.44 plus minus minus 1.34x. This is the complete equation. Okay, what we have done in step number 3, step number 2 everyone has understood. Step number 3 was make equation. Put the value of A and B, B is minus, so plus minus minus. Now in last step we have to put the value of only x. So number 4 is estimation. Number 4 is estimation. Price x is equals to 20 rupees. It is given in question. Estimate the demand when price is 20 rupees. So price x is 20 rupees, comma demand y is equals to question. Y cap is equals to A plus bx 31.44 minus 1.34x. 31.44 minus 1.34 into 20. 31.44 minus 1.34 into 20. 26.8. So I am writing here. Y cap is equals to 31.44 minus 26.8. 4.64 100 units. The unit should be of y. The unit should be of y, 100 units. So this much is enough for us. Again we are repeating the sum. Starting from the first step, that is regression coefficient B. Formula as x bar and y bar both are integers, so x minus x bar, y minus y bar divided by x minus x bar square. Don't forget, don't keep that square root here. So b is minus 1.34. Now A intercept y bar minus bx bar. Use x bar and y bar. A is 31.44. Now we have to make the equation. So fitting regression line y cap is equals to A plus bx. Put the value of A and B. 31.44 minus 1.34x. This also has marks. Now last they are telling to estimate price is x is equals to 20. Then demand y is how much? Then keep the equation, and in equation x is equals to 20, so we will get y cap is equals to 4.64. Unit is of 100 units. So friends, we have completed first sum. Now tomorrow we will go for the 2, 3 and 4th sum. So that's all for today. Write what we have given very fast. Thank you.